Hey guys, so you've been asking for it, trigonometry. Now, this video is going to be geared towards all levels. If you're doing trigonometry in Form 1, Term 3, or if you're doing it in Form 4, or trying to recap in Form 5. Either way, here are some basics that relate to trigonometry. So on screen, I will draw my standard right-angled triangle. So if you guys can recall, trigonometry deals with right-angled triangles. Okay, so once we have our right angle in there, we need to learn how to name the sides of our triangle. So we have three sides. Our three sides are called 1. We have the hypotenuse. 2. We have the opposite. And 3. Our third side is called the adjacent. Okay, so we have three sides that are used to name our triangle. But how do we decide which side has which name? Good question. Now, with that right angle triangle, one of the first things you definitely will have in your triangle is the presence of that 90-degree angle. So wherever you find you have a side that's directly opposite your right angle triangle, that side is actually called our hypotenuse, and it's commonly denoted by the letters H, Y, P for short. Okay, so we've learned how to name one side. What about the other two? Well, in our triangle, in order to identify the hypotenuse, we use the presence of the right angle. So perhaps if we had more angles, we would be able to identify the other two sides. Now, very frequently in trigonometry questions, you do have a second angle called theta. Now, theta can be on the bottom here, or theta can also be here. Now, wherever your theta is found, you simply have to use that as a reference point in order to determine the names of your sides of your triangle. So for example, if our theta were in this location at the top, then the line that is opposite that angle of theta would be called our opposite. And we'll denote it by OPP for short. Finally, in this question, because we have already successfully figured out 2 out of the 3 sides, then by default, obviously, our third side is called the adjacent, or ADJ. So I showed you an example where we had theta at the top. What if we had theta at the bottom? Would it affect the names of our sides? Well, let's see. So what I'm going to do here is I'm just going to, I'm going to draw a second triangle, just a tinier one. Okay, and I am going to input my right angle. And this time, I am going to include my angle theta at the bottom there. Now, let's try and name on our sides this time. So once again, we recognize our right angle is located here. So directly opposite, we have our hypotenuse. Similarly, we recognize that our theta value is located at the bottom. That's no problem. It's still opposite this side of the triangle here. Because our angle is opposite this side, then for this diagram, our opposite would be called for this line here. And then finally, by default, our last side, the adjacent, would just be that missing side that we have not yet named. So some points to note: you can always find your hypotenuse located opposite your right angle triangle. You can find your opposite side located opposite your value for theta. And then finally, your adjacent can be found by default. So 1, you can find your adjacent by default because it will be the only side that has not yet been named. Or your adjacent, if you observe, your adjacent in the first triangle, your adjacent is that line that has your angle theta as well as your right angle triangle. Similarly, in diagram number 2, your adjacent has your right angle and your theta. So if you don't want to go by the default method, and let's just say you only wanted to figure out which side was the adjacent, well then it would be the side that usually contains your required angle and your value of 90 degrees. So there you have it, guys. That's a very lovely way of determining how to name the sides of your right-angled triangle.